The two topics for this unit are compound interest and continuous interest. And compound interest, basically it's interest on interest instead of just interest on the principal. Interest just on the principal is what's called simple interest. Here's compound interest. Let's say we have an amount, let's say P. Let's say $100. Okay? If I multiply it by 1, I get the money back that I invested, plus R, which is the rate. So if I distribute, here's the amount I get back that I started with, and here's the interest, the principal plus the interest. That's what I get after 1 year. Here's what I have after 1 year. For the next year, I start with this, don't I? And I multiply by 1. That'll give me the money back that I started with, plus R, the interest. And if I keep doing that year after year after year, do you see that I have interest on interest? So after 1 year, after another year, after another year, so I could say that the total amount is going to be P, the amount I start with, and 1 plus R, and I'm going to have N of these for the number of years. So P is, always start with the principal, R is the interest rate, and N is the number of years. But that's after 1 year, after 1 year, after 1 year. Let's say we compound interest monthly. So what will happen there is we'll have the same formula, but instead of giving you the whole interest after 1 month, we're only going to give you a 1/12 of the interest after 1 month. And if I do this each month during the year, I'm going to have 12 times that I'm going to compound the interest each month, after each month. If I do this for multiple years, like after 2 years, I'll have done it 24 times, 3 years, 36 times, the number of months in that many years. So to make this formula more general, we'll take the interest rate and divide by the number of times we compound the interest. If it's monthly, it's 12. If it's weekly, it's 52. If it's daily, it's 365. And the number of times we do it is the number of times per year times the number of years. So T here is the number of years. Let's fix this other formula. Let's call this T. That would be more understandable. And we'll call that time in years. So actually, we can just use this formula, because if I compound once per year and the ends become 1, then this formula is just like this one. So here's 3 examples where the principal or amount I start with is $10,000. I'm going to do it for 5 years, and the annual interest rate per year is 1.32%. So if I look at the amount equals the principal times 1 plus r over n raised to the nt. Well, t is the number of years, so that's 5. The rate is going to be 0.0132. We convert the percent to a decimal, and P is the amount I start with. That's the $10,000. Alrighty, so in example 1a, here's our $10,000, here is our interest rate, and we do it for 5 years, once a year for 5 years. If I do it semi-annually, that's every 6 months, every half year. Semi means half. It's $10,000. Here's the one that keeps our $10,000. Here's my interest, but after 6 months, I can only do half of the interest. So I divide that by 2. So every 6 months. If I do that for 5 years, every 6 months, aren't I going to do that for 10? I'm going to do that 10 times every 6 months. That'll be 10 total times I do this. Quarterly, I divide the interest rate by 4. So in 5 years, I will do this 20 times if I do it quarterly. So let me show you how to use the calculator and this formula. So what I can do is go to y equals, there's something there, just clear it out, and then I'm going to do 10,000 parentheses 1 plus, and let me make my fractional exponent, so that's like second second about alpha fy equals, there it is. So alpha 1, and 1 is the fraction. Okay, let me do this. Let's start over again. So clear, second quit, y equals and we'll have 10,000 parentheses 1 plus alpha and f1. If I choose 1, I can make a nice fraction. Each fraction is going to have the 0.0132 on top, and on the bottom, that's going to change. So I'm going to call it x. That's the key next to alpha. Go to the right, close the parenthesis, and caret, we have an exponent of 5 because it's always going to be 5 years, and the number of times per year is also the x. In our formula, that's n, but on the calculator, I have to use that as x. Enter. Now to use this formula, I'm going to do second and window, which is table setup, and I'm going to go down to, I'm going to ask for the x value. So I go down there, go to ask, press enter, and I want the answer or the dependent variable to be automatic. All right? Then I go to second and graph, which is table. But since I did second, it's not the graph, it's the table. And it's blank. Well, in the first case, x or n, the number of times I do the interest rate is 1. So if I type 1, it's asking me for the x value, but it's automatically going to give me the y value. Now if I go up and to the right and go on it, do you see that there's more to the answer than what shows up on the table? And since we're talking about money, let's round to the nearest cent. So we have $10,677.66 if I round to the nearest cent. And now because I have this table, I can go down and to the left, and I can type in 2 for the number of times per year I do the interest semi-annually, and press enter. And if I go on to that answer, we see that we have $10,679.95. So the more often I compound interest on interest, I get a bit more money. Lastly, if I go down and to the left to the next x value, and if I do it quarterly, it's 4 times per year. Enter. Go on top of that answer, and we see that we have $10,681.11. We can see that at the bottom of the screen on my calculator. We have 2 more to go, so if I go down and to the left, and now we're going to do it monthly, so 12 times every year. For 5 years, that'll be 60 times. Enter. And let's go on to that answer to see what it is up to the nearest cent. That's $10,681.88. Last but not least, let's do it every day, and so that's 365, assuming it's not a leap year, and go on to that answer, and we get $10,682.25. Doesn't grow as much, but it is a bit more.